When it comes to building IoT sensors, the best power consumption is no power consumption. That's why I'm talking to Jan and William from Nanopower. Hi Jan, it's great to see you here at Electronica 2024. Now you're with Nanopower and a startup in the space of exactly what you do. Produce stuff that uses just nano power. Tell us a little bit more about the company and how long you've been around.
Yeah, so we're a fabless semiconductor company, and we're launching the nPZero. We call it a power-saving IC. So it's something new in the market and in a disruptive way when you design a system. And this is a enabling technology to reduce power consumption. So our main mission is to reduce the power consumption in constrained battery-sized systems. And yeah.
Now, what would you say to expand on that energy-saving aspect? What sort of engineering challenges do you see your customers being faced with, and how are you fixing that problem?
So now you always need to have an active host running the system. But what we do, we come in between the host and the sensors, and we will be the manager of the entire system and manage the power both for the host and the sensor.
And so I imagine then you're also talking about applications that are today maybe trying to move from a battery to an energy harvesting type solution. Is that the sort of space that would be well suited to this?
Yeah, so it's battery powered devices and also energy harvesting devices. And also we see a shift now for system that couldn't be done on battery power. Now we are enabling that, and you can make battery powered devices in smaller devices.
Yeah.
And since we're also reducing the power consumption, you can have a smaller device due to a smaller battery, but also reduce the overall size of the entire device that you're making. So it's a cost reduction in the overall system.
Yeah. And who do you see as sort of early adopters of this technology, and what sort of applications are they building?
So now it's a lot of wearables and trackers. We have UV trackers in logistics, and we have a list of developers in the back here who just launched the early adopter program.
Right.
In order to have them ready when we are launching the product now in Q1 2025. Yeah.
Super. Well, thanks very much for those overview of the market, and all the best with the product.
Okay, thank you.
Hi William, it's great to have the opportunity to talk to the CTO of Nanopower. This is your baby. Tell me a little bit more about the nPZero product. What is it and how is it architected?
Okay, nPZero is an IC which is a master-slave architecture to enable more efficiency on a system. So we are the man in between the host and the sensors, where the control is handed over to our IC. We shut down the host and we manage the sensor in a really highly efficient mode. So we are able to power cycle sensors, put them to work when they are needed. So when the sensor or a slave is not needed, we don't need any type of information, we completely shut it off, so no leakage. And when this happens, our system is looking at the sensors, draining only 50 nanoamps. Wow. So we drop power consumption a lot.
So I've got all my I2C sensors, my SPI sensors connected to your device, and you're sort of taking this approach where no power is the lowest power, we can say.
Yes.
But when I'm maybe turning some of those sensors on and off, I guess some of them require some time before they can respond or before I can have a trustworthy measurement. Yeah. How do you support and handle that and help customers to make sure it works?
So first of all, our interfaces are industry standard. So we follow I2C and SPI communication protocols. So we have methods of recovering if something goes wrong. Like we have I2C stretching, we have retry counters that can be configurable, so the system never gets hooked up. So the main goal of our technology is to lower power, but if we have a system that its maintenance free, lives forever, it cannot get stuck. So it's really important for us to have mechanisms to recover if something goes wrong. So we follow, and we are always looking at new ways of avoiding lockouts in the system.
Now, I understand that the nPZero and the technology you've developed is based on a technology called sub-thresholds in the semiconductor industry. Tell us a little bit more about that and why you've taken that path.
Okay, so the subthreshold operation is the lowest power operation you can run on silicon. So, but it's not readily available to use on any foundry because simulation tools are not really reliable in this technology. So, what we have done is all blocks in our IC, analog and digital, are fully developed by our IC team, and we do all the characterization internally to fine-tune the models of simulation, and then we come back to silicon to check if everything is correct. So when we build some new block, we always have it fully available in silicon to do characterization in our lab. So we are sure that what we design is reflected in silicon, and we are completely sure if we add more blocks, we put them together, they run as we wish, and they drain the current we expect them to drain.
Yeah.
So, yeah.
So if we zoom out again back to the system level, for a developer who's currently got a system in place without the nPZero, what sort of current power saving improvements could they see by taking this approach?
Yeah, this all depends on the use case. So the more often you read the sensor, so if you get to the limit where you never are off, we don't help that much. But when we start to have like 1 second period, 2 second period, 15 minutes, 1 hour, 24 hours, like gas meters and so on, you can have improvements of more than 1,000 times. It all depends on the use case. But most of the times, we are on the 10 to 20 times less with the same outputs. We don't reduce quality of the signal. We don't reduce quality of data. We just manage in a better way the sensors.
Yeah. A key thing for engineers looking to try technology for the first time is sort of hardware evaluation boards and maybe software for configuration. Have you got anything in that space?
Yes, we have both. We know that people don't have time to develop because they have so much to do in following up customers and trying to deliver new solutions that we have the evaluation board. It's basically a carrier board which has an Arduino Uno compatible pinout and has PMOD also compatible connectors where you can put any type of sensor. So in this carrier board, the customer can insert a hardware Uno type of shield, like a Nordic semiconductor or other type of vendor, into our carrier board, which has already our chip inside, and they can plug any type of sensors. And to ease the task of testing this, they don't have to do any type of code. We have a graphical interface where they, only with dragging blocks and checking boxes, they can set up the hardware to operate in the mode they think is the best. So they evaluate this in 1-2 minutes, they test it with their own hardware, and then our tool outputs code snippets they can put directly in their main file, and they can run it in their system already without the simulation or the tool we have.
Yeah.
So it's basically they found out locally with their firmware, the operation mode, it will be exactly the same as the tool we provided with the simulation.
Now, one of the big challenges in this particular field is measuring
Yes.
low power, and we're talking like 10s to 20 nanoamps. I mean, what sort of tools measurement tools are you using to do that?
Yeah, we have specific lab current measurement scopes, which are normally, it's not easy to find them on any lab of a company. So we have options to help such engineers to be sure the system is running that low. So if they can measure till few hundreds of nanoamps, they still can measure some parts of the blocks working. If they want to really be sure we are on the 50 or below nanoamps, normally we work together. We ask them to ship the boards to us, and we do the full characterization, and sometimes we help them optimize the code. So sometimes they think they have all peripherals off, and sometimes they don't. And we say, okay, this is not really in the mode you expected.
Yeah.
Something is not right. And we help them debug the application, so they are more into shutting down no needed peripherals, and then they are on the right track in battery optimization and power consumption in their systems. So we work together, we try to help people because our success depends on their success. If they are not really succeeding in reaching the low power for them to compete with another brand, and they have they win the challenge, we are not winning the challenge either. So we want really eagerly to help them achieve the goals of low power.
Now, for somebody who's watching an interview today and is interested and excited by the technology, where can they go to maybe get some samples, get an evaluation board? What's the best thing to do?
Yeah, the best thing is contact us directly, go to our website, and we have a lot of demos. We have contacts details in there. We have early adopter programs, which include samples, include engineering support. So it's the easiest way.
Fantastic. Well, I find it an absolutely fascinating topic.
Right.
I think you've done a great architecture with the device, and I really wish you all the success for its development in the coming years.
Thank you.
If you've enjoyed my interviews with the movers and shakers from the deep tech industry, follow me, Stuart Cording, the Electronics Reporter.